Hello, so we are back. Sunday. And after long research, check here. You see those sparks? This is solar power. I came up with a working system. So our solar system is kind of ready, okay? So we have the controller, we have the batteries, and we have the inverter. Now with the inverter, I am impressed about this inverter. And keep in mind, this is some kind of no-name inverter. But I think this is the best what the money can buy. And I don't think you will find another one like this. On a side, it's saying it's Sun 1000 GTIL2. I tried to find a website, manufacturer website. I couldn't find it. If you know, just leave me a link, because I'm looking to buy an external limiter and I can't find the website. I bought this from Amazon, but on Amazon it's on different name. Amazon, I think, is on Amazon you can find it like Eco Worthy. But I'll leave a link on the description so you can have a look. Anyway, let's speak about this. So I go with the Inverter controller, like how we test the controllers. You remember the charging controllers? Actually, that test was pretty accurate. So I didn't choose the first one, the BN series, because I read that some people, they have issues with the some kind is getting frozen and they have to do a soft reset. So I choose the second one, okay, the AN series. Now we have two calcium acid lead batteries and the inverter. But the inverter is kind of special because it has a power limiter, okay? So like now, let's see if I can show you. Probably not. So right now, how you can see, you see the voltage, 227, the main voltage, but under the voltage, right now, the sensor is sensing, actually the power going through that wire is 436 watts. On the middle, you can see the output current, output wattage, power, and it's 0. From a simple reason, because it's set up to start only at 28 volts. That's how I set up the inverter. You can set up a startup value and a stop value, okay? Just to don't discharge the batteries, and just after that leave them to charge. So it's pretty straightforward. And you see that current, you can actually see the current because of that sensor. So this inverter, it will start if the voltage of the battery is right and if you actually take the power. Okay, so we'll wait for the battery to get charged and we will see together how it's taking power based on the load. The sensor is just a simple thing. I'll show you 1 second. So let me grab the sensor and I'll show you. That's the sensor. It's nothing special. It's just inside is just a coil around 125 ohms, but has a direction. So actually the inverter is figured out the current direction. Yeah, it's a bit more complicated than that. Yeah. So that's how the inverter is figured out, the direction of the power and actually the power itself, okay? Now, so outside is a bit sunny and cloudy on the same time, but have a look on the software. So you see the battery, 227 volts, 227 volts. So you see the current, 436 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 volts. So you see Hopefully you can see. So you can see the we have the solar information, the amps, the voltage, the power, the output power, the battery voltage, and we have the graph. Obviously you can see here when the sun is going under the clouds, the power goes down. So right now we are taking out from the solar panels like 417 watts, but it's cloudy like how I said, and it's around 947, which is not the solar peak of the day. But it's a nice piece of software to monitorize the actually what's going on in your system. Okay? Now I will stop the camera and I will start after the battery will be charged, so we can see actually how the inverter is working. So see you in a bit. Okay, so we are back. The battery reach the startup voltage for the inverter. The sun is still up, but it's still cloudy. We are taking out from the solar panel 9.4 amps, and the controller, the charging controller, is converting to 19 amps, 24 volts, which is a decent value. Right now we are taking out around 450 watts from the solar panel, but like how I said, it's only like 40 past 9. Okay, so now the inverter starts, okay, and it's outputting. Let's have a look together. Okay, so check there. You see the voltage 228, and that's the wattage what is actually taking from the mains, from the grid. So it's taking 6-7 watts, but actually the inverter, it's outputting to our load, yeah, 405 watts. So you understand how this works? Actually the inverter is now outputting power outside. So right now he is providing 440 watts because that's the load. Yeah, that's the load. On this circuit I have like 3 computers, and that's the power that those computers are taking right now. And from the grid, that's very important. What power is taking from the grid right now? It's taking like 8 watts. So that's how this inverter is working. Okay? It's pretty nice. You see, 6 watts is taken from the grid. You can see under the voltage. 6 watts from the grid, 105 watts from the inverter. Let me connect the heat gun. Okay? So I'll connect the heat gun. So now the heat gun is start. So look what happened. So it's taking 753 from the inverter, and what is left? 375 from the grid. Now it's off. If it's off, the power goes down. I still have the power supply on. So the power supply is on. It's taking only 7 watts from the grid and 105 from the inverter. If I start the heat gun, $745 from the inverter, and obviously he cannot supply the whole power, and still is taking 382 from the grid. Now we are charging the battery with like 20 amps. We are taking out from the solar panel 500 watts, and math is like that. So the inverter is taking out from the battery 16.7 watts. You can see that, yeah? Now the charging current is this, but you can't see it. So the charging current, 11.9 amps. You can see that, yeah? So we are charging with, let's say, 20 amps. And the inverter is taking one more time 60 amps. So we are fine. Right now the battery is charging and actually is running the inverter. So I think we have a final solution for this. I think that's the cheapest solution. So this, everything, I think it's around 600 pounds. 600 pounds for, I don't know, I will try to check to see how much power we can take, let's say in one sunny day and one cloudy day, and probably there will be our next video. But one more time about this controller, this inverter, sorry. I did some research. This one. So let me show you where is what is actually, what is the sensor. So you can see the sensor there. So just try to imagine, yeah? That power is coming from your grid, from your electricity provider. So we have an extension where the inverter is plugged in, and actually where it's our load plugged in. So that's what the inverter and that sensor is doing, is not letting the power to go in that direction, so the power can go only on our direction. So we can only use that power. The power is not getting wasted. Now, apart from that, there are people trying to develop some things for this inverter. Like they try to control this sensor. It's a little bit more complicated. And I did some research. And I thought, you know what, it's just a signal from 0 to something, I think 0 from 0 up to 5 volts on the external limiter connector, PWM signal. But it's just a bit more complicated because of the direction of the current. And I didn't know actually you can figure it out, the direction of the current on an AC circuit. But looks like I still have a lot to learn. So that's what that sensor is doing. That sensor is nothing, it's just a coil. But he has inside a circuit, so he can figure it out, the direction of the current, because obviously the inverter is not meant to put the power outside. You have to send the power outside, it's just meant to use inside. Okay? So I'll stop now and I will see you probably on the next video. Speaking about the battery, you know, I really try again to review my option with the batteries, but still these are the best option. For myself is the best option. Okay, the batteries are cheap. Our next generation of lead acid battery, these are calcium lead acid batteries, which they have double life compared with the normal lead acid batteries, because there is they replace the antimony with calcium and it's less gassing, and that's mean longer life. I set up my system to charge my battery up to like 85% and discharge down to 45%. So we can use some power from these batteries. But even if you think you'll buy the lithium iron phosphate batteries, even those ones, you can't discharge them more than 20%, where they are 20% up to like 80%. So from there you have to use, you can use like 60% of the power, and we are using here how much? 45%, yeah. So I think I'm happy with my 45% instead of paying 10 times more for the lithium iron phosphate batteries. I'm really sorry, but this is just a cheaper option. I can buy 10 batteries. We save money buying one batteries, yeah, a lithium battery. So I'm going forward with those batteries, and I'll keep you in touch. I'm still trying to figure it out. It's a little bit more complicated than I thought, because soon as this inverter, this can get out from the battery up to 35 amps. And I have in a menu to set up a limit of the current. The menu is very nice. I can set up a current limit, I can set up even a wattage limit. So in the moment when this is taking 35 amps from our batteries, yeah, on that point all the voltage are messed up. The voltage drop a little bit, not too much, but the controller is seeing the voltage in a different way, is charging a different way, so we have somehow I have to figure it out to match all those voltages, yeah? Even this one, the startup voltage, the stop voltage, so they have to be matched, okay? But I will still do more research and I will let you know exactly on a final solution, yeah? So have a great Sunday and see you next time. Bye.